I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
Every time Jam says chemistry, he points. The chemistry of everyday life.
Yeah, it's so weird. I do that. Huh.
You do that.
I think it helps me know which thing I should emphasize. And it's like, a lot of these words are important, but chemistry is kind of the more important one, at least for our podcast.
Well, we've got a couple of disclaimers for you here at the beginning, and then we're going to jump right in. Mm-hmm. The first one is that I'm recovering. I am blissfully healed from a terrible illness in which I was wiped out for several days.
Yeah, she was very much wiped out.
Very wiped out.
We had to alter our recording schedule. And like, normally I think everything else would bend to recording in your life.
Yeah.
That's kind of the way I interpret it, you know?
Absolutely. I mean, it's one of my favorite parts of the whole week, so.
Yeah.
Maybe not my schoolwork, though.
Well, yeah.
And so if you hear me cough or if my voice sounds a little bit different, that's why. I'm on the upswing. I feel a lot better, but there's still some weirdness in my throat.
Totally. And I'm going to do my best to get all that stuff out of there so they don't have to, you don't have to hear that if we can help it. So. And
I've got those cough drops powering me through, so that helps. The second is we're going to change things up here a little bit at Chemistry for Your Life. And the reason why is because I'd like to do a quick shout out. My mom is so sweet and she's so kind, and she is a nice person. She would do anything for anybody. She's like so mild-mannered. Have you ever met her, Jam?
Yeah, I think a couple times. Yeah.
Would you agree she's that way? Yeah,
oh, yeah,
she's so sweet. Everyone I've ever met loves her. I've never met anyone. My dad is very polarizing, not my mom. And I was talking about a different podcast, and she said, oh, do they talk a little bit about their lives at the beginning? And I said, oh yeah, they do. Almost all podcasts do.
Yeah.
You know, that's pretty normal. And she said, And I said, why, Mom? Why do you ask? And her response was, I just don't really care about anyone's week, and I just wanted you to get right to why Jam's pot didn't boil. And I thought it was so funny. I was not offended at all. I thought it was hysterical that my mom, who birthed me and brought me into this world and should really arguably care about my week more than anyone,
right,
didn't want to hear about my week.
Yeah.
Which I know she wants to hear about my week. She loves it when I call her. She just wanted to get straight to the science.
Yeah.
So we're going to try for the next few episodes switching things up a little bit.
Okay.
And instead of doing our week in review at the beginning, we're going to do something that made us happy about the week at the end.
Okay, sweet.
And this will make people like my mom and my roommate, who are tired of hearing about my week, happy to hear about the science first. And then those of you who do care about my life and Jam's life, you can stick around and hear about it at the end. Yeah,
hopefully it can be kind of a happy medium. So it's not like such an extreme change that now one camp, so to speak, is happy and the other one's not anymore. Yeah. So hopefully that's the case. But we'll see.
I like hearing about people's lives on podcasts. So
yeah, I
think hopefully you guys will appreciate that. And if not, we would love to hear your feedback. We want to hear from you guys.
Yep.
So absolutely. Let us know.
Don't hesitate.
Don't hesitate. Okay. Are you ready to get started?
I am ready.
Great. So this week, do you want to know what we're going to talk about?
Yes, please.
Do you remember when you asked what the scientific word for sticky was?
Oh, yeah, I do remember that. When was that?
I have no idea.
I think, what the heck? When was that?
I don't know.
Oh, wait, which episode did we talk about sugar on roads? Because that's, I think, when it came up.
Oh, it was the colligative properties.
So
why didn't Jam's pot boil that one time?
Yeah. The one that your mom wanted to get to the chase on, yeah. We have a fun thing for that for the next Q&R episode. Someone did a little bit of research on that. Whoa.
I'm really excited.
Okay, interesting. Yes, that's when that came up initially. We were talking about how it would be sticky on the road or whatever, and then, I asked the question.
I'm glad you remembered that.
What is the scientific word for sticky? Worded it something like that.
And I couldn't think of it, and there's a good reason why, but we'll get back to that later. But you know who did think of it?
Who's that?
There's two people. The first person who wrote in was Adil H.
Oh, yeah, and we don't know him. He just emailed us, which is pretty awesome.
Yeah, thanks for writing in, Adil. And then our second person who wrote in was Josh C. Yeah. So they wrote in with the word adhesive. Adhesive, which is a great thought. And I don't know, that did not come to me at all, but I'll talk about why I think it didn't come to me.
Okay.
So thank you, Adil and Josh, for writing in. That was really fun to get your responses, and we love to hear from listeners. So that was great.
Absolutely.
So let me ask you this, Jam.
Okay.
When you think of sticky, what do you think of?
Man, a few things come to mind. Like we talked about the sugar kind of stuff. So sugary things come to mind. It's like one of the first things. Like you got your candies. Mm-hmm. I use honey on a pretty regular basis. So that's something that comes to mind for me. It's like, I guess it is sugary, but like it's naturally sweet, but it's sticky for sure. And like glue. I mean, I use all kinds of different glues or wood glues. I just recalked our shower recently.
Oh, I don't like that word.
I know, it's a kind of gross one.
Yeah. I don't think I like AUL words, just as a rule.
I re-siliconed our shower recently. That was very sticky. So those are the kind of things that come to mind for me.
Great. Well, I'll say this. So there's two categories of things we could go with.
Okay.
One is sticky, the types of things you were talking about earlier. Your honeys, your tape, your glue, your silicon. That's our one category of sticky. And our other category is stuck together.
Okay.
So that's different than what you think of when you think of sticky honey or glue between your fingers. It's two things that have adhered to one another and are permanently stuck together.
Okay, so like it's not about the feeling on those, is what you're saying?
Yes.
Okay.
So think of if you stick two things together with wood glue.
Yes.
When you start, the wood glue is sticky.
Yeah.
When you finish, the wood glue has stuck two things together.
Yeah.
But it's no longer sticky feeling.
Right. It doesn't feel sticky, but it is sticking. It is like doing what it's supposed to do.
It is stuck.
Yeah. Yeah.
So I kind of want to explore that. That was where I got hung up on, because always in my education, I've learned these two really words for sticky, these two quote scientific words for sticky.
Yeah.
Adhesion and cohesion.
Okay.
And I always think of when something is adhered together, that stuck, not sticky, but stuck. And so I got really in. That's, I think, why I couldn't think of the word adhere, because I have that in one category in my mind.
Okay.
So in my research, I wanted to explore that. Does that sound good to you?
Yes, it does. This distinction's like pretty interesting, because I don't think it crossed my mind. It makes sense. I mean, it's just like it had not really crossed my mind. I don't know.
Well, now all the forces behind adhesion and cohesion, it all is a result, things that stick together. This is a broad statement, so I'm going to qualify, but I think every single thing that is sticky or is stuck together is as a result of the same thing.
Okay.
Do you want to know what that thing is?
Yes, please.
It's a big jargony word.
Okay.
It's called intermolecular forces.
Intermolecular forces. Have you used that phrase before?
Mm-hmm.
Okay.
I have. So we use that, I think, 2 times.
Okay.
One time in the soap episode.
Yes.
And one time in a Q&R episode.
Okay.
So I'm just going to give a really brief overview of intermolecular forces.
Okay.
We don't have to dig too deep into them. We have talked about them before because they're at play in so many things.
Yeah.
And I think in the next few episodes, we're going to explore more of what they cause and more stickiness.
This sounds like it's the kind of thing that could fit into the category of the dark side of chemistry. It's the forces, you know what I mean? The force.
No, the force is good. May the force be with you.
That's true, but isn't it the bad side too?
May the intermolecular forces be with you.
Yeah. Okay, so maybe it is the good side then.
I think it's the good side, yeah. Okay. Because it is underlying so many things.
The dark side was the trans fats and stuff like that, right?
Yeah.
So this is the good side.
Unexpected negative ramifications.
Okay. So now
there's none of that here.
Now we have the force. Okay, good.
Okay, so we have the force. May the intermolecular forces be with you. Intermolecular forces are, all they are is the forces between two molecules.
Okay.
The attraction between two molecules.
Okay.
So when we talk about adhesion is the attraction between two molecules that are different. So just pulling two off the top of my head, water and carbon dioxide.
Okay.
The intermolecular forces between that is what causes them to be close to one another. On the other side, cohesion is what causes the forces that cause two of the same molecule to be attached to one another.
Okay. Like they're bros. They're the same thing. Okay.
So water, two water molecules that are attached to or drawn to one another, that is cohesion. Water and something different, that would be adhesion.
Okay. So you have a glass of water. You've got a lot of water molecules in there. Cohesion. You've got carbonated water?
No. You've got regular water. No, carbonated water too, but I was going to say, you've even got adhesion in your glass of plain water because it's the water and the glass molecules. Silicon dioxide, in case you were wondering.
Got it. I see what you're saying. Okay. I was thinking about just the liquid itself, but you're saying like, yeah, it's also, obviously it's staying in the glass. It's,
Yeah, it's not just got a force field around between the glass and the water. The water's just floating inside the glass.
Yeah.
So that's adhesion is the water to the glass. Cohesion is water to itself.
Nice. Okay, that's pretty simple.
You've got adhesion and you've got cohesion.
Okay.
And the reason those things stick together, intermolecular forces.
Okay.
So intermolecular forces, there's a range of different forces. There's some basic ones that are present in everything. There's some really strong ones. Those really strong ones are called hydrogen bonding.
Okay.
It's between two molecules. And basically as a result, just as a brief overview, as a result of the way the electrons are arranged in the molecule.
Okay.
We talked about in the soap molecule polarity in the soap episode. Also in the soap molecule, there's polarity in that molecule.
Right.
So that has to do with how the electrons are arranged in the molecule. If the electrons are bunched around one side, they're more negative there. The absence of the electrons on the other side creates a positive.
Okay.
Because there's the positive center of the atom surrounded by the negative electrons.
Yeah.
So if the electrons are moved off to one side of the molecule, that side's going to be more negative, the other side's going to be more positive. Do you remember that?
Yes, I do. Yeah. And we talked about magnets. And so, like, is that being like, there's like a positive, negative? That's a common thing that we all deal with.
Yes.
Is magnets. So are all the intermolecular forces to some degree dealing with some positive and negative stuff going on?
Yes.
Okay. So it's like, there's a lot of electron stuff, but at the basic level, it is positive and negative, like we've talked about.
Yes, exactly. Okay. That's great. So you've got it.
Okay.
And hydrogen bonding is basically a special type of very strongly polar.
Okay.
Very negative on one side, very positive on the other to create a strong pole on either end.
Okay.
So then when you have that present in a molecule, it can bond to other molecules better because their negatives will line up with the positives and vice versa.
Okay.
Does that make sense?
Yeah, it does make sense.
Can you just say that part back to me real quick?
So it sounds like intermolecular forces in general are based on positive and negative, kind of like the soap molecule, or magnets. And whenever you have really strong positivity and really strong negativity, if you have something that has really strong on both ends, when it is going to be bonded to something else, it has a much stronger bond because its positivity and negativity are really strong.
Yes. And that was a great understanding. The only thing I'll maybe tweak is it's not really a true bond as much as it is between two atoms. They're just closely held next to each other.
Got it.
So rather than your fingers being stuck on your hands, imagine it basically holding hands with someone else.
Okay, got it.
So the stronger the intermolecular forces, the closer and more intertwined the two atoms are.
Okay.
And the weaker the intermolecular forces, the easier it would be to maybe break apart that hand holding. Maybe holding just one pinky.
Okay. I had a teacher one time who, I don't know where she got these. I think it was like from some super old speakers. She had these insanely strong magnets that she used on her marker board.
Oh, wow.
And they were really flat cylinders. They almost like those discs that are like watch batteries.
Yes.
It was like that, but really big. And it was so strong. I mean, I was like a kid, so I couldn't pull it off, but she could as an adult.
Yeah.
So that comes to mind for me. Like, I've not encountered magnets that are like that strong.
Yes.
Other than in that scenario, and they've always stuck in my mind. Like, I kind of wish I could have some strong magnets like that.
I think magnetism is a result of something slightly different, but that's a good parallel that everyone has experienced.
Right.
There's those weak magnets that fall right off your fridge every time you close the fridge door.
Yeah.
And then there are those strong magnets.
Yeah.
So weak intermolecular forces are that way, where they'll basically at the slightest bump break apart. And there's strong intermolecular forces where they will hold tight together.
So it's okay for me to use that as my like connecting to the, as an analogy, but it's not at all what's driving what's going on.
Yes.
I can't use that to explain magnets, but I can use magnets as an idea to explain this.
Exactly.
Okay. Sweet.
So that's a really good understanding of intermolecular forces. And just remember, the strongest ones are called hydrogen bonding. Okay.
Got it.
Now, that explains intermolecular forces explain everything that adheres, or as cohere a word, either has adhesion or cohesion present.
Okay.
So you have intermolecular forces in water. You have intermolecular forces in DNA. That's what hydrogen bonds are actually what cause that double helix.
Oh, interesting. Okay.
There's intermolecular forces in everything. In the wood that I'm looking at, the cells that are present in our bodies have intermolecular forces. Everything has intermolecular forces at play. If there's a molecule, there's intermolecular forces. Unless you have somehow isolated one molecule away from everything else in a vacuum.
Yeah.
I don't know how you could possibly do that.
Well, that makes total sense, because then it's like, if there aren't, everything would just fall apart all the time.
Exactly.
Like we just all be like one massive puddle of gush.
And intermolecular forces are responsible for a lot of things. So they're going to come up a lot through our whole show forever.
Okay. So this is a building block. I need to like definitely retain this. Not that I shouldn't other stuff too, but
well, they're just going to come back up a lot.
Okay.
So we know that two things that have adhered together likely have strong intermolecular forces between them. The stronger the intermolecular forces are, the harder it's going to be to break apart. So you can even think about this in boiling point. Something with a very low boiling point, it's easy to pull those molecules apart and turn it into gas.
Oh, yeah. Okay, interesting.
Something with a very high boiling point, it's harder to pull those things apart and turn it into gas. Okay? So water has strong intermolecular forces. It has hydrogen bonding. So it has a relatively higher boiling point than something that has not good intermolecular forces. Okay.
Got it.
But let me ask you something. Is that stickiness, do you think?
I guess it's not in the way that I might happen to use that word in my daily life, but it is stickiness in the sense that those things are sticking together.
Yes.
You're referencing like, yeah, that is the root of what we mean when we say sticky, even if we kind of have we have kind of like an undefined category of what we describe as sticky. And we don't typically think of it as like everything, even though it kind of is.
Yes. So that's kind of what I ran up against. When I was thinking about adhesion, I was only thinking about that being adhesion and cohesion being molecularly things that stick together well. But my definition of sticky is something sort of different.
Yeah.
And I think we have a lot of ideas of stickiness that we imagine like sticky things, like our fingers sticking to stuff. It all has to do with this touch sensation. And I think that's different than the molecular sticking, because something that has incredibly strong bonds or intermolecular forces, it's even often not even categorized as intermolecular forces, but our salts. They're so strongly bound together. Literally, one thing has lost an ion and another thing has gained it. And it's so hard to break them apart. Their boiling points are astronomical. They'll usually just degrade before they will boil.
Whoa. Like even like this like table salt kind of thing?
Yeah. Oh, yeah.
Whoa.
Absolutely.
Interesting.
And so you have table salt, and that has very strong intermolecular forces, but it's not sticky.
Yeah.
There's some argument about that in the scientific community, whether you can truly call an ionic bond an intermolecular force. That's a gray area of science that doesn't matter a lot. I won't bore you with the details, but it gets the point across that I'm trying to make.
Those things are very stuck together. Whatever you call it.
Yes.
They're very stuck together.
Yes.
Okay.
They're very stuck together, and it's very hard to break those bonds, and it doesn't give the same sensation of stickiness that we feel.
Definitely not. I mean, even like, yeah, like you could get some water and some sugar and it can get sticky. Water and salt doesn't. But the salt is very much stuck together.
Right.
Huh. Okay.
Well, and not the ions dissolve, so that's kind of a different case, but that comes up against exactly the hard time I had in this research is, what is stickiness that we feel?
Yeah. Yeah.
I think it's something different.
Yeah, it really is.
And I looked up some online, and honestly, I wasn't satisfied with any of the answers because I could have a chemical argument for them the other way.
Got it. Okay.
So my final judgment is that stickiness has two categories. Stickiness that we feel and how well things are stuck together.
Okay.
How well things are stuck together, adhesion for two different molecules, cohesion for the same molecule, all about intermolecular forces. There's chemical bonds. Those are all things that are stuck together.
Okay.
That's a chemical definition. I think what we experience is a particular thing that has to do with viscosity and the presence of hydrogen bonding.
So it is still sticky in the chemistry way.
Yes.
And also sticky in a tangible way.
Yes.
Okay. Got it.
I think so. And I think this gets into some gray chemistry. I don't think we can explain everything about the sensation of feeling in touch. If there's somebody out there that knows more about this, we'd love to hear from it and do a correction. But hydrogen bonds are very strong intermolecular forces. They're different than ionic bonds, but they're very strong intermolecular forces. And they're present in sugar, honey, all of those things that we traditionally experience as feeling sticky.
Yeah. Yeah.
But there's also a viscosity to them.
Yeah.
Do you want to explain what viscosity is, just for the listeners at home? I've heard you talk about viscosity a lot, so I know that you know what that word means.
Well, it's one of those things that you like retain from back whenever you took science classes, whenever you or whatever, and you just had to throw it around like, oh yes, viscosity. But my understanding is that it's just like, it's something that's pretty thick. Like it doesn't, like water will just kind of flow. It has like, it's easy for there to be droplets of it. You could like put some in your hand and just kind of or whatever.
Yes.
But other things like honey, as the example I used earlier, thinking about sticky stuff, it's really thick. It really wants to stay together. It really does not want to be pushed around. It's kind of stubborn.
Yeah. So that is a resistance to flow. Is basically viscosity is a measure of resistance to flow.
Okay.
And it has to do with more than just intermolecular forces. Intermolecular forces are at play, but with increased temperature, some of those intermolecular forces will break up and it runs more. You know, you've experienced that with honey.
Yeah.
This morning I was trying to put honey in my coffee that was iced. It did not work well. As it cooled down, it resisted to flow even more. So there's something to, I think, our feeling of stickiness that has to do with viscosity plus our experiencing of the intermolecular forces with as they interact with the oils or whatever is present on our fingers. Why are you laughing?
I keep like, I was trying to figure out if I should say this or not, but it's got me chuckling. Okay. So,
oh gosh.
So one of my roommates and I like to on purpose say words wrong that like are kind of near what is really intended.
Yeah.
As if it's like, we do it pretending like we're doing it on accident.
For example, pacifically. You say pacifically a lot
or
instead of specifically.
Vicious and viscous is a really funny one. Like, yeah, that dog really turned really viscous all of a sudden. It was just so strange. And doing that, pretending like we don't know. And just, I mean, like we think it's really funny for some reason. But the idea that people might think we actually have those things mixed up is really hilarious.
Jim has a weird sense of humor.
So viscous and vicious is a funny one. Pacifically and specifically is really funny.
Okay, so all that to say, well, I think you overshadowed my point a little bit, which is I think that stickiness has to do with the way, not only the viscosity of the feeling that we experience as stickiness, rather than how well bonded together two things are, how stuck together they are molecularly, I think has to do with viscosity in addition to hydrogen bonding, in addition to the way that the molecules in that substance interact with the molecules that are on our fingers. Yeah. I think all of that comes into play. So I do think it is a more complex issue than we can just answer by simply slapping hydrogen bond on there.
Right.
But I think that hydrogen bonding answers the majority of the reason why.
And all those things combine together to create an uncomfortable thing that we try to get rid of as soon as we possibly can.
Yeah.
Like you get a little bit of honey left on your hand somehow. You are like, get this away from me, please.
Oh, absolutely.
Like, that's so funny.
Yes.
Man, science.
So that's it. So do you think you got it?
I think I got it.
Okay, so I want you to talk to me about stickiness. Teach me about stickiness.
Okay, so stickiness, we typically think of just the feeling of it. Like it's a thing that feels sticky on our hands or in some way that we're interacting with it.
Right.
Honey, glue, sugary things, whatever.
Right.
And so there's a level to which on the chemical side, its ability to be sticky has a lot to do with the intermolecular forces because it is able to actually have things that stick together, or in the case of a sticky substance would be using, it'd be adhesion, because it's, say, the honey in our fingers or something like that.
Right.
So it would be, us interacting with something else and it'd be stuck to us.
It might be a combination of adhesion, the honey in your fingers, plus the honey with itself.
Right. So that's the chemical kind of side, like deep on the molecular level. But then another thing that we experience is really easy to see is how a lot of those substances are also really viscous, and thick, and just resistant to flow.
Yep.
And so that both those sides, the very visual, very easy to see with our eyes part, the viscous part, and the molecular part are what give us this very sticky experience.
Yes.
Is that right?
Yeah. I think that's a great definition.
Did I miss anything?
No, I think you got it. So that, I think, is the chemistry behind stickiness that we experience. I think you did a good job of characterizing it. And then there's also the idea of how well stuck together things are. And in my opinion, that's almost a different topic altogether.
Because everything's stuck together in some way.
Everything's stuck together in some way. It's much more complex. But I think you explained it well. I did realize I forgot to say viscosity, in addition to intermolecular forces and temperature, has to do with the shape of the molecules. We talked about shape of molecules and how well they fit together in the margarine and trans fat episode. So you can listen back to that if you want some more about that.
The shape matters. Got it.
So, and this is something we talk about in Gen Chem a lot, is you'll learn these basics of chemistry, but there's a lot of gray areas or things that we maybe don't know, or you can't say 100% sure it's just this thing. And that was what I came upon today when I was researching this. There was more to it than just what I found to be available in my research. I think that there's a deeper level that we're missing, or some explanations that aren't fully there. But I'm happy with what we landed on.
Yeah.
Okay. So that's our episode on the scientific definition of sticky. Now I want to hear, what is one thing this week that made you happy? So
one thing that made me happy this past week is I got to go to the beach. In Texas, we put air quotes around it because it's Galveston. It is a beach. I'm not too good for Galveston. It's just that a lot of people, if you say beach, they might think you went to one of the like really well-known ones or something like that. Like,
white sand, blue water.
Yeah. And over in this part of the Gulf of Mexico, it's not quite as picturesque, but very enjoyable, very relaxing. Went there with friends. It was fun. Drank a lot of coffee. Went on some runs around the beach and stuff. I saw this really cool dead fish that was like,
oh gosh,
bleached white. Had some stuff, crawling around in it and everything.
Crawling around in it?
Took a photo of it. I'll absolutely share that on Instagram, so you guys can all appreciate it as much as I did.
We should put censor over.
yeah, we'll blur it or whatever, something like that. It's really not super gross. The photo is not quite as much as being like. I mean, that's how I guess a lot of dead things are that way.
Yeah.
Seeing a photo of it, it's like, just looks like a fish that's not really moving.
Yeah.
You can't see a lot of the detail or smell it. But in person, there are a lot of sensory things.
We should talk about the chemistry behind bad smells.
Oh my gosh, I have so many questions about smell.
There are reasons that things smell bad to us, and we shouldn't ignore it. That's all I'm going to say.
Oh my gosh. So yeah, that's mine. What about you?
Gosh, there are so many things to be thankful for. I'm feeling better. When you feel better after you're sick, suddenly you're thankful for things that you're never thankful before, like breathing.
Absolutely. Oh my gosh. Yes, for sure.
So I could talk all about that. Or Emily had this beautiful fall candle just set up for us when we walked into the studio.
Hazelnut cream scented.
Oh, it smelled so good like fall when I walked in.
Mm-hmm.
So I could talk about all of those things, but I think that was my sneaky way of talking about 3 things.
Yeah. That's kind of cheating.
What I'm going to talk about is I have some friends who are 6 years old. They're twins. And I lived with this family when they were first born, so I've known them their whole lives. And
that's pretty cool.
It's really cool. And it was so kind of that family to let me stay with them. And I got the opportunity to, someone at the place where I skate, the skating rink, it's a Stars Center, gave us free tickets to the Stars game to where all 4 of us could go. And it was so fun. It was their first time on their train. It was their first time at a professional game. And their eyes were so big. They had so much fun. And it was so much fun for me to share something that I really like. And I remember when my dad took me to that first game.
Yeah.
That is something that is in my mind forever. And so to know that they got to have that same kind of experience was so fun.
Yeah, that's cool.
Yeah, we got to spend so much time together. So that was a very bright spot.
Yeah.
For me in my week.
Oh, definitely. That sounds like that's not an average week either. That's like a cooler than, like that could be the thing that made you happy for like a month or whatever. You know what I mean? So
yeah. So that was really fun. So I think that's going to be my thing that made me happy this week. So.
Cool. That's awesome.
Yeah. Well, thank you guys. Well, first of all, thank you so much to the Stars Center for those tickets. We want to give a shout out and thank all of you for listening and for learning today. I hope you had fun learning about stickiness.
Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we definitely want to hear from you. If you have any questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts, ideas, and questions. If you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts to help us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam Robinson is our producer, and we'd like to give a special thanks to who reviewed this episode.